In math, just like in many other areas of life, we will be making use of formulas. A formula is just a way of taking what we have and turning it into what we want. In chemistry, we have a formula that shows us that water, when you add electrical energy to it, will break down into hydrogen and oxygen gases. When baking, a recipe serves as a formula, telling us how to turn basic ingredients into a delicious cake. In math, our formulas are equations that state the relationship between two variables. You've seen this formula for the area of a rectangle. It says that if we know the length and the width, we can multiply them together to get the area. Notice that in algebra we do not use an x for multiplication, since x is commonly used as a variable. So the rule is, whenever a number is next to a variable, or two or more variables are next to each other, those numbers are multiplied. We're going to be practicing substituting into formulas and expressions. When we are looking at the examples, I suggest that you pause the video and try them on your own. Then resume the video and check your work. So let's take a minute to find the area of a rectangle that is 20 by 16. We know the formula for a rectangle's length times width, so I'm going to substitute 20 in for the length and 16 in for the width, giving us 20 times 16, or 320. Let's look at another example. Jane is starting a new exercise program. Her instructor told her to keep her heart rate between 70 and 85% of her maximum heart rate. To find the maximum heart rate in beats per minute, this formula is often used. If the maximum heart rate is equal to 208 minus 0.7 times the person's age. So let's estimate the maximum heart rate for Jane, who's 15. To do this, we're going to be substituting 15 in for A. Remember, using the order of operation rules, we're going to be multiplying 0.7 times 15, giving us 10.5. And then we're going to be subtracting that from 208, giving us a maximum heart rate for Jane of 197.5 beats per minute. Like so many real-life problems, the answer we got is just the starting point for the problem, not the ending point. Because what we really want to know is that for a 15-year-old like Jane, when she is exercising, what range of numbers should she be keeping her heart rate between? So, can you find the range? To find this range, we will be multiplying her maximum heart rate times 70% for the lower end and times 85% for the higher end. First, we'll need to convert our percentages to decimals. So for the lower end, that would give us 0.7 times 197.5. And the higher end of that range would be 0.85 times 197.5. In mathematics, parentheses also can mean multiplication. So when we multiply that, we'll get that she should keep her heart rate between 138.25 and 167.875. Now we're almost done with the problem. We need to think about how we want to present our answer. It's hard to count a quarter of a heartbeat, so do you think we should express the answer in real numbers, or would whole numbers make more sense? Well, the heart rate is in beats per minute, so you could think about it in terms of a quarter of a heartbeat. But if you think a whole number would be better, then we should round our answer and tell Jane that when she's exercising, she should keep her heart rate between 138 and 168 beats per minute. Now let's try evaluating the algebraic expression 3 times the quantity 4a minus 3c divided by a minus 3, when a is equal to 5 and c is equal to negative 2. The first step is always to replace the variables with the given values. So we'd have 3 times 4 times 5 minus 3 times negative 2 divided by 5 minus 3. Since there's both multiplication and subtraction, we will, of course, multiply what's in the parentheses first. So that would give us 3 times 20 minus negative 6 over 5 minus 3, or 3 times 26, which is 78, over 2. 78 divided by 2 is 39. Let's look at one more situation. Would the equation 2x equals 3y minus a plus 7 be true when x is 5.25, y is 2.5, and a is 4? To check to see if those values make the equation true, we will start by substituting our new values in for x, y, and a, giving us 2 times 5 1/4 is equal to 3 times 2 1/2 minus 4 plus 7. That would be 10.5 is equal to 7.5 minus 4 plus 7. Well, 7.5 minus 4 is 3.5. We add 7 to that, we get 10.5. So both sides of the equation say 10.5, and we know that for those values of x, y, and a, the statement is true. The fact that we can evaluate an expression when we know the value of the variables that are being used forms the bedrock of algebra. We'll be using this constantly from here on out, both directly and indirectly, to make sense of all other concepts that we will see.